Okay, today we're going to go through how to do a rotation on a coordinate plane. And so again, when we were talking about a rotation, we're talking about moving an object around a point. There's going to be two things that we kind of consider. We're going to have our center of rotation, which actually in this case, most of the ones we do, or actually all of them in this set of notes, will all be around our origin. And then we'll eventually get to ones where we're rotating it around a point on the plane. Then the other thing is the angle of rotation. The degrees that we're rotating it today will focus on 90, 180, 270, and 360. And then the last thing is just like with the previous two transformations, we know that rotation is going to be a rigid motion. So it means that all the angles and the side lengths are going to end up being the same. So they'll produce a congruent shape when we do that. And so for our counterclockwise rotations, we have rules that we can use for these counterclockwise rotations. So for our rotation of 90 degrees, um, we can just kind of notice a pattern here. So we start with the ordered pair 2, 3. And then a rotation of 90 degrees counterclockwise is the ordered pair -3, 2. And then -1, 3 is 90-degree counterclockwise rotation is -3, -1. And so what we should be able to notice through the first four examples that we have there is that our x and y coordinates are trading places. And then if we notice, um, our after we flip our x and our y coordinates, the new x coordinate is always going to end up changing signs. So we highlight each one of those, and we notice that these two flip, so it becomes 3, 2, and then this one becomes negative. These two flip places, this right here changes signs. These two flip places, the new x changes. These two flip places, and this changes. So when we do this, kind of the rule that we're going to make for ourselves is we are going to flip our x and our y. So we're going to change their places. And then after we do that, we're going to change the sign of our new x coordinate. And so for this one right here, the ordered pair -3, 4, what I'm going to do is I'm going to change the sign, or sorry, I'm going to flip my x and my y, so it's going to become 4, -3. They just traded order. And then I'm going to change the sign of my new x, so it'll be -4, -3. Same thing with this one right here, the last ordered pair right there. I'm going to flip them. It's going to become -9 and +5. So I just flipped my x and my y. And then I'm going to change the sign of my new x. So that will become a +9, +5. Those will all produce a counterclockwise rotation of 90 degrees. Same thing just by looking at our pattern over here with the 180 degrees. What we'll notice here, 2, 3, -2, -3, -1, 3, 1, -3. So the x and the y coordinates aren't flipping, okay? But both of them are changing signs. The x coordinate and the y coordinate are changing signs. So our rule is going to be that we're just going to change the sign of x and y. So to do a 180-degree rotation, this will become 3, -4. And then the last one will become -5, +9. So just changing the sign of both of them, nothing's trading places. Then the last two that we have down here, 270. Again, if we kind of notice, we've got a similar thing happening where our x and our y's are trading places. So I'm flipping my x and my y. And then what we'll notice is the one that's changing signs ends up being our new y coordinate each time. So we're going to change the sign of our new y. So I'm always kind of doing it in order. Flip the x and the y, change the sign of our new y after we flipped. So once I do this, so I'll have 4, -3, I flipped my x and my y, and then I'm going to change the sign of my new y to become a +3. When I do this, it's going to become -9, +5, Then I'm going to change the sign of my new y, so that'll become a -5. And then the very last one, a rotation of 360 degrees, it doesn't change at all. 360 degrees just brings it back to where it started from. So nothing changes. So when we do this, we can just go ahead and follow these two examples. So we got vertices, we're doing a 90-degree counterclockwise rotation to this shape. So let's see, we got ordered pair 1, 1, 3, 3. It's P, Q, 4, 1, 1, 2, 3, 4, 1, and 3, 0, 1, 2, 3, 0. So shape looking like this. Good. And so really all I want to do is just apply my 90-degree rotation rule. And so again, just kind of peek up here. My 90-degree rotation rule, I'm going to flip my x and my y, and then I'm going to change the sign of the new x. Flip my x and my y, and then change my new x. So if I go with my p prime, so I flip my x and my y, change the sign of my new x. Flip my x and my y, change the sign of my new x. So for my r prime, flip my x and my y, change the sign of my new x. And then for my s prime, flip my x and my y. Can't really change the sign of a 0, so just going to end up becoming 0, 3. And so when I do that, now I can plot PQRS prime. So -1, +1, -3, +3, -1, 1, 2, 3, 4, and then 0, 1, 2, 3. Just like that. P, Q, R, S prime. Right there. I'm going to fill that in kind of just so we can see what we ended with. And so again, what I should notice and what this should be illustrating is around the origin, I am moving this shape 90 degrees that way. It's a 90-degree counterclockwise rotation. Then moving on to the last one that we have here, 270-degree rotation. And what you'll notice here is a 270 and a 90-degree rotation are really, really similar to each other. So with a 270 counterclockwise rotation, I'm still going to flip my x and my y. It's just now I'm going to change my new y, the 270-degree rotation. And so when I do that, so I'm going to go F prime, G prime, H prime, and I prime. And so again, I flip my coordinates for F, my x and my y, so it becomes 2, -3. And then I change the sign of my new y, so it becomes a +3. G prime is -1, -3. And then I change the sign of my new y, it becomes a +3. H prime, I flip them and it actually stays the same. -1, -1, change the sign of my new y. And then I, 1 flips to 1, 0. And again, I'm not going to be able to change the sign of the 0. So I can go ahead and plot. Oops, I should plot my pre-image first. My FGHI. So -3, 2, F, -3, -1. H is -1, -1, and 0, 1. And then now my FGHI prime It's going to be 2, 1, 2, 3, negative 1, 1, 2, 3, negative 1, positive 1, and then 1, 0. There we go. I'm going to color that in. And again, kind of the same idea as what's happening here is around my origin, all these pieces are going 270 degrees all the way around. Oops, I should probably go from H all the way to H prime, which ends up being right there. That's 270 degrees. I should put my primes on there with each one of those. Just like that. So those are the rules. Those are rotations of 90, 180, 270, and 360 degrees. And then down at the bottom, so if I wanted to do a 90-degree rotation clockwise, what rule would I have to use? So think about if I've got a coordinate graph and I've got, some sort of box in here, okay? And I want to go clockwise. So again, clockwise is going around. So a 90-degree clockwise rotation would end up putting this over here. And so the question is, which rule? Because I don't have a clockwise rule. I only have counterclockwise rules. So going 90 degrees clockwise would be the same as going all the way around here like that. And so that would be like a 270-degree counterclockwise rule. And then the same thing would be true with the next one is if I wanted to do a 270-degree rotation clockwise with that same thing, I'd end up with like that. And so again, if I am going here 270 degrees like that, it would be the same thing as going 90 degrees counterclockwise. Sometimes it almost makes more sense thinking about it in terms of like a quarter turn or a 3/4 turn. Going the opposite way, it would just be a quarter or 3/4. So um, just know that I think there's a question on the homework that talks about doing a clockwise rotation. And so we have to make sure we understand with clockwise rotations, we have to use counterclockwise rules. And so just understanding which one goes with it. So um, that's it.